In this series of forensic science lecture, today we are discussing about the forensic identification of fiber. We have discussed about the fibers, the various types of fibers, what are the natural fibers and man-made fibers. After going for that, we must look into what are the different tests we conduct for fibers. So, we should conduct those tests before which are non-destructive in nature, because the sample which is being procured from the crime scene is very few, is very less and cannot be procured again. So, the main motive for the identification or for the forensic examination of any evidence, the first techniques should be visual examination, microscopy, and then we should go for further analysis of different tests. So, when we are talking about the testing of fibers, there are various tests which are being done after the visual examination or microscopy. We have burn test, where we can burn the fiber to know its odor, appearance and the color of the ash. But burn test is a destructive technique. This should be done when when the microscopic test or the visual examination test or other tests are being done. So, the thermal decomposition of a fiber tells it about what is the components there. We can go for the chemical test also to know the solubility of fibers in different liquid. For example, the hydrochloric acid or sulfuric acid or strong bases like NaOCl, acetone, NaOH, this determine about the polymers of different fabrics. Another important factor which we can see for the analysis of the fibers is the density. We all know that the density of water is 1 gram per ml, and olefin is the only fabric that will float in the water. When we talk about the optical properties of the fibers, we talk about the refractive index and the birefringence. Refractive index, as we know, it is the bending of light as it passes from air into solid or liquid. So, any forensic investigator, we measure the refractive index of an unknown sample with the liquids of a known refractive index, and we place the sample in different liquids until the bakelite is no longer visible. So, we know the birefringence is the difference between the refractive index whenever we see the fiber along the axis, it is parallel to it, and the axis towards it, perpendicular to it, then the difference between those refractive index is known as the birefringence. Birefringence is the another optical property which we analyze for the fiber identification. Other optical properties when we are talking about is fluorescence. We can look the fibers under the UV light and we can find the differences. Various laundry soap and some bleach reagents, they cause blue light to be reflected, making it appear a lot whiter. So, the optical properties when we are talking about, we look for the refractive indexes, birefringences, fluorescence, and these are all the non-destructive techniques for the analysis of the fibers. When we talk about the dyes which are being used in particular fabric or a fiber, we have to go for the thin layer chromatographic analysis, in which we have to dissolve our fiber into a particular chemical or liquid where the dye will be extracted out, and that can be run on a TLC plate. We will discuss the techniques in details. So, the dye gives the color to the fiber, which we call as the fiber color. Color influences the value given to a particular fiber identification. Various dyes are used to given to a fiber to reach a desired color. So, that becomes the point of identification in forensic analysis. For example, if the fiber is of a color which is made by combination of 3 to 4 different colors, then it has 3 to 4 different dyes which can be known using various other techniques. So, individual fibers, they can be colored prior to being spun into yarns, which can be further dyed, and the fabrics made from them can further be dyed. So, we can see that at every different level a dye is being added to different fibers. So, when we have encountered any fiber at the crime scene, the dye from those fibers can be extracted and we can know that how many different dyes are being added to that particular fiber, and those can lead to us like this particular fiber matches with the suspect fiber or not. The fiber which is found at the crime scene matches with the suspect fiber or not. Color can also be applied to the surface of fabric which is found in the printed fabrics. However, the color which is applied and absorbed along the length of the fiber are important comparison characteristics. Sometimes when we know the bad quality of dye is being applied, then we can also see that there could be some discoloration or the color fainting in such cases. So, primarily when we have encountered any fiber evidence which is being encountered at the crime scene and transported to the forensic science lab, after visually examination, after noting down what are the different colors of that fibers, how many different types of fibers are being encountered, the first and foremost technique which we go for is microscopy. The fibers should be first examined using a stereo microscope. Why stereo microscope? Because it gives us a 3D image. It will tell us various physical features of that particular fiber. We can know about the length of the fiber, color of the fiber, diameter of the fiber, luster. Luster means how that particular fiber is giving a shine, its cross section, damage, and we should also know whether there is any debris which is being adhered to that particular fiber, and in a tabular form everything should be noted, whatever we have observed under the stereo microscope. Other microscopy techniques which are being used could be polarized light microscopy or the normal compound microscope. So, whenever we are analyzing the fibers, they can be further classified into the broad groups. So, whenever we are observing under a microscope, we can make a tabular chart. We can first tell whether the fiber is natural, it is organic, inorganic, synthetic, man-made, whether the sample contains any yarns, thread, any cross sections, or it is a combination of 2 or 3 different fibers. Everything should be recorded in a tabular chart. If there is any twists and turns present, the number of colors present in that particular fiber or fabric, so all those should be noted. So, comparison should be made under the same illumination conditions at the same magnification. This we are talking about the comparison of the fibers for the samples which are encountered from the crime scene and the samples which are being collected from the suspect. So, those two samples should be compared under the exactly same conditions. That means the same light should fall on the fibers and they should be magnified at the same x. For example, if the magnification is 10x for the one fiber, it should be 10x for the another fiber also. So, in such cases we can use the comparison microscope also, which requires color balancing and various different light sources. This is best achieved with 2 fibers or fiber samples from the same source which are mounted on 2 microscopic slides and they can be compared directly. We can call them as a side to side match. That means we have kept 2 fibers together, one on the left hand side and one on the right hand side, one collected from the crime scene and one collected from the suspect, and we look for whether under the microscope they appear similar or they appear different. This is the side by side comparison which can be done under a comparison microscope or maybe under a stereo microscope, where we can discriminate between 2 fibers whether they belong to the similar origin or whether they appear similar or not. The physical characteristics of this must be compared under the comparison microscope of the known as well as the question sample, and photography is further recommended so that the salient features should be captured for the later demonstration. For example, if we are going for the microscopic examination, we can use a compound microscope, we can use a comparison microscope, a phase contrast microscope can be used which reveals the structure of a fiber. If there is any animal fiber is nothing but the hair of that animal. So, we can appear for the hair of that particular fiber, we can get back that this is an animal fiber because we know that the fiber does not contain any medulla, but the hairs contain medulla. Then we can go for the electron microscopes, which pass beam through samples and the image can be seen on a recorder. We can compare the images of different scanning electron microscopes and then we can get to know whether the two fibers are similar or not. So, visual examination and microscopy is the preliminary techniques which we can go for to look for our fibers. After that, we can go for the micro IR spectrophotometer. The IR microspectrophotometer, it is a combination of microscope plus IR, that is infrared technique. It can tell us about the organic element which are present in the fibers. The major aim of the spectrophotometer is to separate the light into various different component wavelengths. So, we can visualize our sample under the spectrophotometer. It works on the principle that passing light through something to produce a spectrum, the analyst can read the resulting lines which we call as the absorption lines. Combining the microscope with the spectrometer comes the microspectrophotometer, where we can focus directly on a certain point in which we are interested in. So, we can look at that particular fiber in such cases. In those cases, we can get both a magnified visual and a IR pattern at the same time. We are going to learn about the techniques which are used as the confirmatory analysis and to know about the dyes. The first one is thin layer chromatography. We know that chromatography works on the principle of adsorption. It is a valuable technique for analyzing fibers, especially the dyes and pigments that get color from them. Thin layer chromatography is a very easy to use technique in which we have to first extract the dye out of the fibers. This technique is particularly useful in forensic investigations as well as quality control in textile productions, where we can get to know whether the dye which is being added to the particular fiber is of low quality or is of high quality. There are different steps which we follow in TLC. The first step is extraction of dye. We can use a combination of chemicals, for example methanol, ethanol, acetone, or a mixture of any solvent. The dye can be dissolved using these solvents, and this dye which is being dissolved, it does not damage the fiber structure. We will take a drop of this mixture and then we can load this sample on a TLC plate. So, the first step would be sample preparation. Second step would be applying the sample. We know we can spot a sample using a capillary tube. A thin capillary tube can be used, or we can use a spot applicator. We have to make the concentrated spot at a particular position. That means the sample from the dye mixture can be added repeatedly 4, 5, 6 times so that the spot should be concentrated. That means the amount of sample which we have on the run on the TLC, it should be in significant amount. After spotting, we have to look for the stationary phase, which is a silica gel plate which can be made in the lab or which we can purchase from different manufacturers. So, it could be pre-silica plate which comes directly from the market, or you can make your own silica mixture and make a silica plate. After application of the sample, we have to develop the chromatogram. Now, what is the chromatogram? Chromatogram is the picture which appears on the silica plate. We have to choose a mobile phase. We have to take a container. In that container, we have to put our silica plate and we can cover it. We have to put the mobile phase similar to what in which our sample is being dissolved. The common mobile phases which we can use is water, methanol, ethanol, acetone, acetic acid. The specific mobile phase depends upon the solubility and the polarity of the dye which is being analyzed. So, after the careful selection of mobile phase, we have to run the plate. Sometimes there are certain dyes which have certain different components. So, whenever we are running the TLC plate, those components may separate into different positions, and that the separation of dye on the TLC plate will tell us about how this the composition of dye is varying, and this particular look we call it as a chromatogram. Now, second thing is how we have to visualize the results. Normally, if we conduct the thin layer chromatography of anything which does not have color into it, we have to look for a spraying reagent. But in the cases of a dye, the dye is automatically and already covered. So, this colored dye, we don't need to use any spraying reagent on our plate. We can just calculate the RF. The RF, how it can be calculated? It can be calculated by the distance travelled by the solute divided by the distance travelled by the solvent. So, if the dyes which are used differently in different samples, the RF of those dyes will be different, and then we can say whether these two different dyes are similar or not. So, RF value varies for different dyes. We have a library where we have certain standards or references and whose RF values are being noted. So, in such cases we can get to know whether the dyes are similar or different. After running the chromatogram, after the dyes have been run into the mobile phase, we can compare different samples on the similar plate. TLC, it provides the fingerprint of the dye composition, and for forensic purposes, dye profiles from fibers at a crime scene can be compared with fibers from the suspect's clothing, and if their RF matches, that means it suggests that they are from a common source. But another important technique which we can go for the fiber analysis is infrared microspectrophotometry. The major advantage of this technique is it is a non-destructive technique. We know IR microscopy or micro FTIR is known as Fourier transform infrared. This kind of spectroscopy uses infrared as the source of light, and we are attaching the microscope so that we can focus on a certain particular point on that particular fiber. This technique is used in textile industry, forensic science, material analysis, which can tell about the fibers and their chemical compositions. Through IR, we can know about the functional groups, whether any OH functional group is present, acetate functional group is present, what kind of polymers are present, that can be known through the IR microspectrophotometry. So, there are certain points which steps taken for the IR spectrophotometry. We know the principle of IR microspectrophotometry is infrared absorption. Whenever any substance or any evidence is there, it relies on the absorption of IR light by molecular bonds. Various chemical bonds absorb specific IR wavelengths and they produce a unique spectrum which we call as the molecular fingerprint of the material. So, whatever functional group is present in our sample, that is being shown as the fingerprint in the spectra of IR. Second principle which is being used by microspectrophotometry is the microscopic combination. So, IR plus microscope become IR microspectrophotometer. The second step is sample preparation. The most advantageous thing is in the minimal preparation is that the fiber sample can be directly put in the IR spectrophotometry in the microscopic plate or stage where the sample is being kept. Another sample preparation technique is the thinning of the sample, the flattening of the sample. Certain times the fiber which we have encountered from the crime scene, they are thicker fibers. So, it is necessary that those thick fibers should be flattened or should be made thin with the help of an heavy object. So, just a thick fiber is there, we can flatten it, and those flattened fiber can be visualized under the IR microscope, or they can be mounted on a IR transparent slide, for example potassium bromide or diamond. So, after keeping the sample under the microscope, we have to focus the microscope. which we can look for the complex structure or the coatings, we can make the setting for the transmission or reflection mode. See the fiber as an evidence. It could be where the light might pass through the fiber. For example, the cloth or fabric which we wear, sometimes we say the cloth, the light passes through it, it is kind of a translucent or transparent cloth. But there are certain clothes in which the light does not pass through. So, depending upon if the fiber is thin in nature, we can use the transmission mode, but if the fiber is opaque in nature, then we have to use the ATR mode, that is the reflectance mode. In the transmission mode, the light will transmit through the fiber, but in the ATR mode, we are using that light which is being reflected from the fiber. So, here the difference is that we have to keep back the recorder after in the transmission mode after the sample, but in the ATR mode as the light is being reflected, so the recorder is kept accordingly. The spectral range for an IR spectrophotometer is generally from 4000 to 400 centimeter inverse. In this range, it shows distinctive absorption patterns. So, after that we have to analyze the spectrum identification and the interpretation. The IR spectrum, it shows the absorption bands corresponding to various functional groups CH, COO, OH, and we can get to know about the various dyes or the additives which are being added into this. The spectrum which we obtain from the IR spectrophotometer, that can be compared with the library which is being provided with the IR spectrophotometer, and it helps us in the quick identification of fibers like cotton, polyester, nylon, wool and various other synthetic or natural fibers. We can also go for the polymer and dye analysis in certain cases through the IR microspectrophotometry. Advantages, as we were discussing, it is a non-destructive technique, microscopic resolution is available, and we can have specific identification or the chemical fingerprint of polymers and dyes in the fiber. Then there are certain limitations also. The complex mixture is difficult to identify, and sometimes if the fiber is thick, then it interferes and some interference can occur in the results. So, TLC and micro IR spectrophotometry can be used as a non-destructive technique, but there are certain information which is missing from these techniques which can be overcome by using pyrolysis gas chromatography. The major important limitation of pyrolysis gas chromatography mass spectrophotometry is that it is a destructive technique. This destructive technique, where the sample is pyrolyzed at a heat of 500 to 1000 degrees Celsius, our sample is totally destroyed. But the details, the results which we get through pyrolysis GC-MS, they are very significant and we can even identify the complex mixtures. So, PYGC-MS, it is an analytical technique which helps us in the identification and characterizing of the fibers, especially synthetic and natural polymers. These technique, as we suggest with the name, it is a combination of three parts: pyrolysis, GC and MS. Pyrolysis is heating the sample in the absence of oxygen at 500 to 1000 degrees Celsius. GC we know is gas chromatography, where we use the principle of adsorption, where we have any inert gas through which the sample is being run, and the mass spectrometry, where the spectrometer shows the compounds on the basis of their mass by charge ratio. So, this combination is pyrolysis first, GC second and the MS third. We directly put our sample into the pyrolysis unit. We can, if the sample is big, we can cut or shred the sample and put it in the pyrolysis unit, and then we load the pyrolysis chamber. After the loading of the pyrolysis chamber, this controlled heating is being done in the oxygen free environment, and this pyrolysis process, it goes directly attached to the GC. So, after heating our sample at a range of 500 to 1000 degrees Celsius, we generate various monomers and degradation products. This pyrolysis decomposes the polymer chains, they generate monomers and small fragments which are unique to that particular polymer type. So, these monomers and degraded products, they are just being added to the gas chromatography separation chamber. We inject it into the GC column and there they are separated on the basis of the principle of adsorption. For example, we use the RF value in the cases of TLC, but in the case of GC, we use the retention time. That means whenever any mixture is being added to the gas chromatography, we see which component comes out first, which component comes out second, and that gives us different series of peaks in the chromatogram. After these sample is being passed through the gas chromatography, they enters into the MS for analysis, where each compound which exits the GC column enters the MS, it is ionized and broken into smaller fragments. Here in the mass spectrophotometry, our main aim is to identify the sample by their mass by charge ratio. As the sample is being ionized and sample has a mass, so on the basis of their mass by charge ratio, we can get peak at the end of mass spectrum. So, when this mass spectra is generated, a mass spectra for each compound displays M to Z ratio of each fragment, and this spectrum tells us about different components. We can identify the pyrolysis product as compared to the reference libraries or the known standards, which allow for the identification of specific compounds in the fiber sample. Data can be interpreted by the chromatogram analysis of the GC, by the mass spectra interpretation and by the polymer identification. The major advantages of this technique is it is highly sensitive and specific, it requires very small amount of sample and we can detect various additives in dye. However, the limitation is it is a destructive technique, the analysis is very complex, we have to go for pyrolysis, gas chromatography, mass spectrophotometry and the cost is very high. Although this technique as being very specific, the results they can give us a major breakthrough in the evidence. So, to conclude, I would say that the presence or absence of fibers at the scene indicate a time frame for the contact. The fresh fiber transfer can be more abundant and less degraded, which can help the forensic scientist to deduce a contact when it is being occurred. These fibers are invaluable in forensic investigations as they can help us in establishing the connections, providing and supporting the evidence, and in some cases we can also establish the timeline for the events. Thank you.